solve two important equations using complex number. Two equations are given by, the first one is x to the power 6 plus x cube plus 1, this is equal to 0, and the second one is x to the power 8, this is equal to x plus 1 whole to the power 8. Okay, these two equation is given. We have to find out the solution of these two, and obviously these two equations can be solved by using complex number, and we use here the complex number in polar form, and we use the result. An important property of complex number, here we generalize the polar form as, if the complex number is given by this z equal to r into cos theta plus I sin theta, where theta is in the principal value, that is minus pi less theta less equal to pi, then it can be write in general form as r into cos of 2n pi plus theta plus I into sin 2n pi plus theta, where n may be any integer, that is n belongs to z. We use this result here. Now we start with the first equation. This is x to the power 6 plus x cube plus 1, this is equal to 0. So it can be written as x cube whole square plus x cube plus 1, this is equal to 0. So this is a quadratic equation in x cube. By using Acharya's formula, we get x cube, this is equal to, is given by minus b, that is minus 1 plus minus root under b square. This means 1 minus 4ac, 4a and c, this is 1 into 1, by 2a, this is 2 into 1. Here we use the result minus b plus minus root under b square minus 4ac by 2a. Right? This is Acharya's formula. And it is clear that this equation is given by minus of plus minus I root 3 by 2. Okay, and we write this is as in the polar form minus cos pi by 3 plus minus I into sin pi by 3, because cos pi by 3 is half and sin pi by 3 is root 3 by 2. Now we write this complex number as cos of pi minus pi by 3 plus minus I sin pi minus pi by 3. So we get cos 2 pi by 3 plus minus I sin 2 pi by 3. Okay, and here we also say that if this is plus or minus, then it can be generalized by this result also. So we generalize the result as cos of, this is 2n pi plus 2 pi by 3, here theta is 2 pi by 3, plus minus I into sin 2n pi plus minus pi by 3. Okay, and here we must write n belongs to z. This is the set of integer, or we can write this result as n, this is equal to 0 plus minus 1 plus minus 2 and so on. These two are same things, and after that we find the value of x. So we get x, this is equal to cos 2n pi plus minus 2 pi by 3 plus minus I sin 2n pi plus minus pi by 3 whole to the power 1 by 3. Okay, now here we write and restriction of n as n, this is equal to 0, 1, 2, because this is a cubic equation and it has 3 roots. So we take only the first 3 value, which are 0, and another 2 are positive value of n. These are 0, 1 and 2. And now we multiply these indices with the angle. How to multiply the indices with the angle? And this is given by 3, here also 3, and n becomes the same, this is 0, 1, 2, and here we write by de Moivre's theorem. Okay, we get it by using de Moivre's theorem. And Now calculating the equation or solution in another one line, as this is cos of 6n plus 2 into pi by 9 plus minus I into sin 6n plus 2 into pi by 9. Okay, here we write this is by 9 into pi, this is by 9 into pi, and here n this is equal to 0, 1, 2. By putting the value of n equal to 0, we get two value, this is plus and minus, and 1 we get also two value, and 2 we get another two value. So we get 6 value or 6 solution of this equation, and this is of degree 6. So we must get the 6 value of x. Okay, this is the complete solution of the first equation. Now we go to the second one. It is seen that the equation looks like 8-degree equation because x to the power 8 is in the equation, but actually this equation is of 7-degree equation. Why 7-degree equation? If we expand x plus 1 root to the power 8, then clearly x to the power 8 term cancel out from the both side. Okay, so this is 7-degree equation. Okay, and so this equation must have only 7 root. Okay, now we first write the equation as x plus 1 by x whole to the power 8, this is equal to 1, and since we divide both sides by x, so here we must take x not equal to 0. Okay, now 1 means we write 1, this is equal to cos 0 degree plus I sin 0 degree, and the general value of this complex number is as cos 2n pi plus I sin 2n pi, where n belongs to z. This is the set of integer. So we write x plus 1 by x whole to the power 8, this is cos 2n pi plus I sin 2n pi, where n belongs to z. Okay, now taking 1 by 8 on both sides, we get x plus 1 by x, this is given by cos 2n pi by 8 plus I sin 2n pi by 8. We directly use de Moivre's theorem here, and this is n equal to 0, 1, 2 to 7. Now here if we put n this is equal to 0, that is the first value of n in right side, then right side gives the result cos 0 plus I sin 0, this is equal to 1, and by putting 1 here we get x plus 1 by x, this is equal to 1, and this gives x plus 1, this is equal to x, x cancel out, so we get 1, this is equal to 0, and this gives absurd result. Okay, for this reason, since there is no value of x for n equal to 0, so we drop this value of n in here. Okay, so we get here n equal to 1 to 7. That is, for each value of n we get one solution of x, that is we get only 7 solution of x, and we already says earlier this is the 7-degree equation, and we must get the 7 root of this equation. Okay, now in usual manner we get this is 1 plus 1 by x, this is given by cos of n pi by 4 plus I sin n pi by 4, and here we write minus 1 in the right side, and using the formula of trigonometry we get minus, this is 1 minus cos n pi by 4 plus I sin n pi by 4. So this is minus 2 sin square n pi by 8 plus 2I sin n pi by 8 into cos n pi by 8. Okay, we write here in place of minus 1, this is I square. And now taking common 2I sin n pi by 8 and getting the result as cos n pi by 8 plus I sin n pi by 8. Clear? And we get x by reversing this result, we get this is 1 by 2I sin n pi by 8 into, we write directly in the upper position, this is cos n pi by 8 minus I sin n pi by 8 by 1. After multiplying numerator and denominator with the conjugate of this complex number. Okay, so we get the result 1 by 2I into, the first term is cot n pi by 8 and the second term is minus, this is I. Clear? Sin n pi cancel out. Now we multiply I in inner position, this is half into I. If we multiply I with this side, this is given by minus 1 and the first term becomes plus 1 by I into cot n pi by 8 and this is given by x, this is equal to half into minus 1 minus, this is also minus because if we multiply I here and I here, this is I square, so this is minus 1, we put I cot n pi by 8. Clear? And taking common minus, we get half, minus half into 1 plus cot n pi by 8, where n, this is equal to 1, 2, 3, 4, 5, 6, 7. Okay, only 7 have of n here, and this is the complete solution of the second equation. Very, very important equation of complex number. Okay, thank you for watching.